Hello everyone, my name is Amit Kumar Singh and I am your master teacher at Vedantu. Guys, here we are going to have the discussion of this KVPY 2018 SX Part 1 Mathematics. So bachcho, here we're going to have a discussion of one of the beautiful application of this paper. So let me just quickly show you that. So as you can see in the screen, the question says, let Sk be the real numbers such that Sk is greater than or equal to k to the power 4 plus k square plus 1 for all the values of k lying between 1 to 2018 close. Okay, then denote n is equal to sigma k, where k is from 1 to 2018. Consider the following inequalities. Okay, then there are two statements. Statement 1 is sigma k xk complete squaring, where k starts from 1 to 2018 is less than or equal to n times sigma k xk square, where k starts from 1 to 2018. Statement 1. And the statement 2 is sigma k xk complete squaring, where k starts from 1 to 2018 less than or equal to n times sigma k square xk square from where k starts from 1 to 2018. So point is that we have to justify whether which of these statements are true and false. So as per the options, both 1 and 2 are true. Option B is first true, second false. Option 3 first false, second true, and D is like both 1 and 2 and false. My point is that, guys, if you want to deal with this question, you'll have to recall your concept that you have learned in statistics. Okay, I'm talking about the variance. Okay, because if you can recall that, you can click this question within no time. Okay, how about that? I'll explain. So now, you guys, let's just quickly look over for the solution. Okay, so bacho, if you want to deal with this question, I'll just ask you one thing. Okay, for statement 1, guys, I will just ask you one thing, guys. Okay, statement 1 is more or less like, I hope all of you will realize that if I want to write a variance of a variable, try to realize the scenario. I want to write the variance of a variable xk having frequency k, having frequency k. If I want to write down the variance of a variable xk having frequency k, guys, how am I going to write? Guys, I will write down the variance expression will be like, just try to have a look, k xk square sigma of that upon, guys, I'll just write it sigma k. Okay, minus, okay, I'll take the mean is what? Sigma k into xk upon sigma k, and then I'll just have the complete squaring. Need not to say over here, guys, k in all the sigma k starting from 1 to 2018. So this is how I'm going to write down the sigma square, which is variance. If it is sigma square, guys, I can safely say that this value is always going to be greater than or equal to 0. I'm sure but all of you are able to understand this point. Basically, I'm trying to recall the definition of variance, but I'm justifying the variable as xk having frequency k. On that very basis, if I try to write down the value of variance, this is what I'll get. If I try to manipulate it, sigma k over here is nothing but n. So I'll just put it back. So guys, try to visualize sigma k xk square upon n is always greater than or equal to sigma k times xk complete squaring upon n square. I have just replaced sigma k by n. Now you just need to see that if I try to multiply this both the sides by n square, guys, I'll get a new relation which is like n times sigma k times xk square will always be greater than or equal to sigma k xk and then complete squaring. Our point is that this is what we wanted to prove, or this is what we wanted to verify in this very statement 1. I hope again, if you just try to look at the statement, this is what exactly it is written. Hence, statement 1 is true. Okay, hence statement 1 is true. My point is that, guys, can we really verify the statement 2 by the same logic? Yes, obviously. Now I'll just get back to the statement 2. Bacho, how about the statement 2? Statement 2, again, I'll just try to check for the variance of what? Guys, variance of a variable k times xk, okay, having frequency frequency 1. So if I want to write down the variance of a variable k times xk having frequency 1, guys, I'll write down my variance as sigma 1 square as, guys, just try to visualize. Okay, I'm going to write sigma If the frequency is 1, so variable is x k comma k xk, so I'll just write it k xk complete squaring and then sigma upon I'll write sigma 1 minus of I'll write down the average, that is mean, okay, for which I'll just write down sigma kxk upon sigma 1 and then complete squaring. So ideally this is what is the value of variance, which is sigma 1 squared. So technically this whole value again is going to be like greater than equal to 0. To me, guys, as per the data, sigma 1 over here is nothing but equal to 2018. Reason? Because k is starting from 1 to 2018. Okay, so I'll just try to put the value over here. Okay, so if I try to modify the relation, guys, simplify, so this is what I will be getting. I hope all of you can visualize this expression, bacho. If I try to rewrite this expression, so this is what I will have. I'm sure all of you will agree. Now but you just try to visualize this expression, because in this expression if I just try to multiply both the sides by 2018 k square, so I'll have this relation, that is 2018 times sigma k xk complete squaring will be greater than equal to sigma k xk and then complete squaring. I just want to ask you guys, do you understand in this very point that n is nothing but sigma k, where k starts from 1 to 2018. So I just want to ask you, I hope we can conveniently consider one thing, that this value of n is always going to be greater than or equal to 2018. This is something which I can safely assume. So if I do that, so guys, I can say one thing, that if I just replace 2018 by n, this inequality is still going to be true. This inequality is still going to be true. And if this inequality is going to be true, guys, this is exactly the statement 2, which is why if you'll ask me, statement 2 is also true, right? Hence, if you'll ask me, guys, among both the statements, statement 1 is also true, statement 2 is also true. So guys, as per the question, the correct option for this question is going to be like statement A, in which both 1 and 2 are true. So Bacho, this was a very beautiful application of the variance. I hope every one of you would have understood and appreciated the solution. Okay, so just stay tuned for more beautiful solutions of the upcoming questions, guys. We'll see you all again. Thank you everyone.